So recording is started. This is not a technology and sensor class. The online lecture on 31st March. Omar is presenting his second presentation on pressure sensors. Okay, Omar, go.
Hello everyone. Today I'm going to be presenting for you pressure sensors and some information about it. Throughout my presentation, I'm going to first explain what is pressure as a general idea, and then pressure sensors and how does they do work. The sensing methods, because we have different types of sensing methods throughout a pressure sensor. What are the pressure measurements that are being measured normally, some applications, and of course the references. So pressure is known to be an expression of force per unit area that a fluid exerts on its surroundings. So as we can see on the right-hand side in the picture, if we have a fluid that is applying some force on the surrounding or on its container, this force per that unit area or that area is going to be the pressure. We can calculate the pressure by dividing the force on the area, which give us a unit, the SI unit, which is known to be Pascal, where 1 Pascal is equal to 1 Newton per meter cube. We have also many other common units, but the most common or the most known ones are the bar and the PSI. 1 bar is equal to 10 to 100,000 Pascal. And we have the pound per square inch, that's the American known one. We also have the atmospheric pressure, the ATM, as you all know. So pressure sensor, as we can see, it is a device used to sense or used to measure a pressure. Pressure sensors also acts as transducers by receiving the physical signal, which is the pressure, and in terms transducing it and changing it into an electrical signal or into another signal by using some of microchips or some electrical circuits to change that signal. It is used widely and in many and different applications to control and maintain some pressure. As we can see in the lower picture, how was the pressure when that cable was stable, and when the pressure has increased, how the metal has changed its shape and the pressure increased. Other names for a pressure sensor are known to be pressure transducer, pressure transmitters, pressure indicators, nanometers, and piezometers. It's also good to note that the output signals are usually two common signals that we use. One which is from 4 to 20 milliamps, and the other one is from 0 to 5 volts signal. These are capable of changing and giving us the output signal that we want, rather than being a needle which is going to be moving, or an electrical signal to show us the value of the pressure. Moving to the sensing methods, we have many sensing methods. We have some which are known to be a force collector types, which use diaphragm or a piston to detect the pressure, such as the capacitive ones. Capacitive, there is a diaphragm inside the pressure sensor, and there is a cavity in there, which in a result give us a capacitor. This capacitor is going to change, it's going to decrease with respect to the pressure that deforms that diaphragm. And in that case, this change of the diaphragm level or the change of the diaphragm will also give us the pressure value. We have also the electromagnetic pressure sensors, which actually record the pressure as a displacement by means of inductance. We have the piezoelectric ones, which are the most common ones and the most used ones in the whole applications, which creates an electrical charge in the response to stress. Stress is also known to be pressure. It can be bending, or it can be twisting, or vibration even. There's also the potentiometric. It is a motion of wiper along resistive mechanisms to detect pressure. We have strain gauge, and we have optical ones also. There are other type than the force collector ones, which is known to be resonant, thermal, and ionization. What are the types of pressure measurements that we usually do? we have an absolute pressure sensor. This absolute pressure sensor measures the pressure relative to a perfect vacuum, absolute vacuum, where there's no pressure at all, which is 0 Pascal, and then it pressures. So if we have a pressure, it will exceed a positive number, and then we will have that pressure value. We have the Guag pressure sensor. It measures the pressure relative to an atmospheric pressure, which is equal to 1 atm, or we could say that if it is negative, then it is less than 1 atm, less than that atmospheric pressure, and it is positive when it is above that number. We have the vacuum pressure sensor, which measures absolute pressure relative to vacuum. And here it's not the vacuum, it's not 0 Pascal, but it is a known pressure, which in that case, if it exceeds that reference value, then it is positive. It is descent, then it is negative. We have the differential pressure sensors, which measures the difference between two pressures. So we have like a chamber with having two pressures, and we would have two pressure sensors to actually detect the difference between these. And it is mainly used in the steam or the chambers used to heat water, actually. As we can see in the right figure, you can see how do we label the absolute pressure, the Guag pressure, and the relative pressure. You could see when they are positive and when they are negative. And that's really important to differentiate between each one. So for applications, we have many applications in terms of fields that we are going to, that pressure sensors are being used in. We have the medicals, we have in normal life, and anywhere we use some pressure sensors. The most important thing is to know when do we use them, or what is the type of using the pressure sensor. We have at first as pressure sensing in a normal views or in a normal aspect, where we can use it in automotives to check the tires pressures, if it has enough air pressure for the tire to be well inflated, and weather instruments. We have also attitude sensing, which is useful in aircrafts and rocket satellites, the weather balloons, to check the attitude actually between two distinct levels in air. We have also the flow sensing, and here to check in some filters and hot seams, as we said. It's important to know how much fluid is going to be pumped inside a chamber or inside a filter. We have also a level sensing. Level sensing is that in this case, we mean the levels in some water or in some deep sea or going into under stages. And it is usually it's usually used in submarines. We also have the leak testing, which is also to know if any leakage is being found in any chamber or in any different type of containers for a gas or any other fluid. These are my references. Thank you for your attention.
Evet, teşekkürler Ömer. Sorusu olanlar var mı arkadaşlar? Soru sorabilirsiniz. Sana Ömer aynı soruyu soracağım. Minimum ölçülebilir basınç, pressure ne kadar hassasiyetle ölçülebiliyor? Bu konuda bilgi var
Hocam
mı?
o şeye göre yani okuduğum kadarıyla bazıları yapılan force'a göre yapılabiliyor. Mesela o force yani 1 gram sahibi olsa da o force yine de ölçebilir. Yani çok az bir miktarla ölçebilir. Tabii hocam şeye de göre measurement yani pressure measurement yapılana göre o da değişiyor. Çünkü o zaman calibration'da da değişiyor. Yani mesela bazıları absolute oluyor. Mesela onların çok düşük olmuyor. Çünkü zaten bir atmosferin altında olsa zaten negatif veriyor. Yani ona göre de.
Evet.
Yani sensitivity 1 gram yani diyebiliriz. 1
Şeyde
gram of the force yani.
Senin anlattıklarının arasında nanoteknoloji kullanarak pressure sensör yapımı var mıydı? Nanoteknoloji.
Hocam nanometer diye geçiyor da ama nanoteknoloji kullanarak pressure sensör bulamadım pek.
Evet. Bu konuda ultra kapasitörler zannedersem ultra kapasitörler kullanılıyor pressure sensör için. O yaygın bir şekilde bilgisi var. İstersen orada o konuda biraz eksikliği tamamla. Ultra kapasitörler vasıtasıyla pressure sensing diye
Tamam.
geçiyor. O eksiği tamamlayabilirsin.